Hi everybody. Wanted to give you a brief rundown on semi-automatic static proxy delegation. This is from chapter 25 of my book Java for Programmers, and it's really about message forwarding, but it's also about automatic synthesis of message forwarding code using reflection. So first question is, what's a proxy? And a proxy is an element that represents another element. So for example, you can have a proxy vote, which is somebody voting for you after you've left the room. It's a slip that sent a note to somebody that says this person's allowed to vote for me. It goes to the central authority in charge of the voting in lieu of appearing and voting in person. So proxy vote represents the vote of the individual. A proxy delegate is a simpler interface to a complex system. So you give the proxy delegate the ability to do some action by virtue of essentially forwarding the message to some other element where the implementation exists. This brings to mind the bridge pattern. A bridge design pattern is a client with an interface and a server that implements the interface, and this is very important for distributed computation. There's generally a means of communicating between the client and the server. It could be simple message passing. The goal is to have a transparent distributed application, and this is key for using remote method invocation. So it looks as though the invocation is happening on the local machine, but the message gets forwarded to some remote machine. So then the question then becomes, well, all right, well then what's message forwarding? And that's just a message being passed from one place to another. In an object-oriented program, message forwarding means taking a method invocation and forwarding it to another instance. That means you defer the implementation to someone else. So here's the class mammal, and we have some property about hair. Mammals have hair. So we return true. Here's something else called movable. And with class movable, we support the move method, which allows us to change the location in 2 dimensions of the object. Now suppose you want a movable mammal. Well, the movable mammal has both a movable instance and a mammal instance. But a movable mammal, it's not something you can get through multiple inheritance of implementation, because Java doesn't have multiple inheritance of implementation. It only has multiple inheritance of interfaces. So what you do is you make an instance of a movable mammal, you pass movable in, you pass mammal in, and if somebody wants to move the mammal, well, you delegate to the movable instance m the move method. So here comes the move method. We go m.move. If we want to know if it has hair, well, you go to the mammal method and check to see if it has hair. So in UML, what we say, and UML is the Unified Markup Language, the proxy uses the implementation of another class. And so the proxy is the delegator, and the thing that it uses is the delegatee. So the mammal is contained by, or has, the proxy has an instance of a mammal, and it has an instance of a movable instance, which it can use to message forward. So a static proxy delegation means that the method invocations are checked at compile time. That means the instance has been constructed and compiled in comparison to some dynamic delegation system, which is done at runtime. Adding methods to the delegatee does not necessarily mean that the methods appear in the proxy. Those methods have to be constructed by the static proxy synthesizer. That could be done by hand or done automatically. Dynamic delegation is different. That's new methods in the delegatee automatically appearing as available in the proxy at runtime, and that's a new feature for JDK 1.3. It's not type safe. Exceptions can be thrown, and using reflection to invoke a string on an instance may in fact cause the string to throw an exception at runtime. The semi-automatic static delegation does compile time checks. It's type safe. The delegatee changes are discovered using introspection and cause a resynthesis of the proxy code by the automatic synthesizer. And the process of Java source code synthesis that occurs, it occurs at a pre-processing runtime. So we create the code and then we have to compile it. So now we have a new time called design time. The input instance to the synthesizer is used to do the synthesis. Then we have the generate time, that's the synthesis itself, where we output proxy code to a file. Then we have the compile time, where the proxy code gets compiled. We have the linking time, where you dynamically link to the proxy code and the classes it uses. And then we have another runtime, where the invoked method in the proxy gets forwarded. So then the next question is, why do semi-automatic static proxy delegation? And the answer is it gives you a better interface to a complex system. You get better code reuse, easier than manual message forwarding. It's type safe, has easier maintenance, and it's an alternative to inheritance. And so then the next question is, well, why did they leave off multiple inheritance in Java? And what I mean by that is no multiple inheritance of implementations. They have multiple inheritance of interfaces, of course. So the answer is, well, it's less reliable because duplicate methods with the same signature must be disambiguated somehow. So you need policy for that. Shadowing, that's when you have one method overlapping another method in the superclass. That's decided at compile time using some technique, whatever the policy is. And then when you have multiple classes being inherited, you need some mechanism for disambiguating that might involve topological sorting. So if one class appears before another class, then that class has precedent. So here's an example of multiple interface confusion. We'll have a trigonometry class, a toolkit that has cosine. And it does cosine in radians. Now we'll have another one that does cosine, but it does cosine in degrees. So now there's a little confusion. Here's called class confusion, which extends both trig radians and trig degrees. And you can't really do this in Java the way it's written now. But when you go to take the double cosine of 90, are you doing it in degrees or are you doing it in radians? You don't get it in Java, but you can do it in C++ or Smalltalk or Lisp or Simula. And the ambiguity exists, and you resolve it using topological sorting. Since trig radians came first, cosine of 90 is going to be cosine in radians. So that's a fruitful source of bugs. There's a thing called diamond inheritance. That's when the base class, such as the stream, is subclassed by two other classes, like the input stream and the output stream, and then you get a third class that subclasses input stream and output stream and is supposed to inherit from stream. And so now we've got a problem, right? So now we're looking at the input-output stream. It's supposed to take methods from input stream, methods from output stream, and combine them into a single I/O stream. So then the question is, well, what's wrong with diamond inheritance? And it has all the problems of multiple inheritance with ambiguity issues. It makes linking complicated. It makes the overhead for each instance grow dramatically. And most of the overhead is in making allocations from the heap. Since memory comes from the heap, making a new instance is as costly as a malloc in C. And what that means is it's perhaps 6 times slower than if you just allocated a homogeneous array and started using it, especially if the array was an array of complex variables. So if you made a new instance of a complex variable for every element in the array, you can expect a severe speed hit. And then you have a fragile base class, and this is really key. You have to constantly recompile all of the subclasses, and that happens whenever the base class changes. So if you go back in here and you change stream, then input stream has to change, output stream has to change, and the input-output stream has to change and be recompiled. So that constant recompilation problem means that you have to spend a lot of time recompiling the code every time you make a change in a base class. So diamond inheritance has good points too. You get the automatic addition of features to the subclass, and in fact what happens is people add features to a class by subclassing. But it creates a single large class, so that's a one-stop shop. Maybe that's good, maybe it's bad. And then you can create toolkits, and maybe that's very nice. And so what I'd like to do now is give you a little demonstration of some multiple inheritance using delegation. So here we're going to create a thing called polluted water. And polluted water consists of some water and some pollution. And the question is, well, what's the water look like? Well, water can be dirty or it can be wet. Maybe if it's frozen, it's not wet. Maybe if it's not polluted, it's not dirty. And it implements some sort of an interface. So here's the interface, is wet and is dirty. The water pollution can be a combination of both water and pollution. We don't know exactly what kind of pollution this is. It could be gas. And so the pollution, we'll take a look at that. It implements the pollution interface, and the pollution interface tries to find out if it's wet or if it's dirty. And we go to the pollution, and we can return whether or not it's wet or dirty. And if it's polluted, well, I guess we'll make dirty true, but we're not sure if it's wet or not. And then if we're going to create something called polluted water, well, perhaps what we can do is we can add to our delegate synthesizer both the water and the pollution. And now we'd like also to find out the date when things were done. So we'll add the date class as well. So this is interesting, right? Because now we have dated water pollution, and now we're going to do some kind of a process. And the process is going to enable us to get information from the water, from the pollution, and from the date. And what this is going to do is give us an interface and a class string, and then it's going to create some sort of a file. And what we'd like to do is run this program and see what happens. So the delegate synthesizer uses reflection and then creates the so-called water pollution date, and it puts it under attachments. So let's save that. And now what we'll do is we'll take a look at the name. And so we see at first there are 32 unique methods that came across, 4 duplicate methods which had to be resolved. And we created the new class called the water pollution date. And what it does is it has an instance. So there's the has a relationship instead of the is a relationship. It has an instance of water and pollution and the date. So that's this class here, the water pollution date. And it can do method forwarding to any of these things. And now there's a new data type here called the water pollution date stub. This is an interface which has all of the methods in water pollution, in water, in pollution, and in date. So here's the water stub, is wet, is dirty. Here's the pollution stub, which is also is wet or is dirty. So you can see how there's a problem. We don't know which is wet and is dirty to use. Here's the date stub, and the date stub has a whole bunch of information about dates. We can take a look at that if we like. And then at the end of the day, we got this water pollution date being generated in our attachments area called water pollution date. And now we can see water pollution date has an equals, and for equals it used the date. So if the object that comes in is a date, it can return equality if it's the same date. That's very interesting. That's a decision, a policy, right? So apparently the pollution, water pollution date is using the last element, the date, to determine the equality. And we might like to change how that works. It has a date in it, that's for sure. The question of whether water pollution date is equal to another instance of water pollution date just because they're on the same date, well, that's another question. Right? We don't know. Compares to works with dates. Clones, we're cloning dates. Hash codes come from dates. You can see where there's a lot of problems here because we don't exactly know where we're supposed to be getting some of these elements. Right? What if they both have the same methods? What if there's method conflict? So then here comes interface date stub, and now we've got all of the stuff that's in the interface. And when we look at the message forwarding, most of it seems to come from date. So then the question is, well, where's the is polluted, right? So we got the water, we got the pollution, but we didn't exactly add anything in here for determining if it is polluted or it is dirty, right? That hasn't been done yet. So that has to be done by hand, or we have to create a more advanced mechanism for doing the decisions about how to disambiguate the classes. And so that's a first example of how the water pollution date works. It's kind of an interesting one, I think. And we can do this by hand as well. Here comes water stub. Here comes a pollution stub. And now here comes water pollution, which subclasses, extends both water stub and pollution stub as a new interface, right? So it's creating a new reference data type. And now we have the class water pollution by hand, which has a class called the water pollution, and it has an implementation of the water pollution stub in it. So here it is. And now what we can do is we can have water and pollution, and now we can do method forwarding and decide which one we want to use. We can use the water, or we can use the pollution. And in fact, if the pollution were frozen, maybe we could put pollution in here instead. And certainly it doesn't change the interface at all, but it does change the behavior of the code, which is one of the reasons why I think they left multiple inheritance off. It can be a fruitful source of bugs. So when we think about water pollution, we know that pollution is not a kind of water. We know water is not a kind of pollution, but polluted water might be a kind of water, but it might not be. So it's a very interesting thing when we start to combine these elements to create new things. And so this is where you find it under Chapter 25 delegation, and there are automatic synthesizers available which are rather more complicated than what we've seen here. Thank you.